Alright, we're going to get ready for your test over trig functions. So starting out, pretty simple. Each of these three words describes a ratio of a triangle, and your job is to make sure that you know which pair of sides corresponds with each word. So we've got sine, cosine, and tangent. And each of those three words describes a ratio of two of the sides of a triangle. And we name the sides using the terms opposite, adjacent, and hypotenuse. Pretty descriptive, so we know that if we have a right triangle, we already know this angle is 90, so we don't have to find that angle. We need to know the other two angles theoretically. And so we're going to mark the angle that we're looking for with an x, and we're going to describe every side in relation to that x. So this side over here, all by itself on the other side of the triangle, we would call the opposite side because it's on the opposite side of this x. The side next to it over here, not the hypotenuse, which I guess we can go ahead and say now, this side here is diagonal, it's across from the 90, it's the largest side of the triangle, however you want to think about it. The largest side of the triangle we call the hypotenuse side. Leaving us with this side here next to it, and adjacent literally means next to, and so when we see this side here next to the angle that we're looking for, we would call it the adjacent side. And so we use those words just to simply make sure that we're describing the sides in a way that makes sense. And then we need to know, again, which pair goes with each of these words. So sine of theta, the sine ratio is opposite over hypotenuse. So you take the length of the opposite side over the length of the hypotenuse side. That ratio, that fraction, is what we call the sine of theta, or the sine of x in this case. I guess I could have labeled that with a theta symbol since that's what they used over here. Now the cosine is a different pair. The cosine is the adjacent over the hypotenuse. Hopefully you've had some sort of creative way of memorizing these three ratios. There's a lot of things that you can say to help you remember. Some people just remember a single word, SOHCAHTOA. If you're going to remember SOHCAHTOA, you might want to remember how to spell it, otherwise it doesn't really help you. SOHCAHTOA. That's typically what I know people remember, so if there's anything else, of course, you could memorize that as well, but just remember something that helps you remember these three ratios. And if you can't tell from that word, the last one, tangent, is OA, so opposite over adjacent. So those three ratios are just something that you memorize, hopefully based off of that word or based off something else that you've learned to use to help you. And you just need to be able to write those ratios, because without those ratios, nothing else on this entire study guide can really be done. Case in point here, let's look at 4 through 6. Find the value of each trigonometric ratio. So number 4 starts off by asking for the tangent of C. Now first off, C is represented by this angle right here. So if we're at this angle right here, we need to keep in mind that the one across from it, the other side, is called the opposite. We need to find the 90-degree angle. The one across from the 90 is the large side, so it's always what we call the hypotenuse. Leaving the one next to it over here on the side, and again, next to means adjacent, so we're going to name that one the adjacent side. So just like we did up above, really you have to be able to identify which side is which, and then you have to know which one is tangent. So which pair of numbers here is tangent? Well, SOHCAHTOA, TOA, tells us that tangent is O over A. So the opposite, which is 36, over the adjacent, which is 27. Now, hopefully like any good math student, you look at that fraction and think, hey, that's big numbers, that's a fraction. I can probably reduce that, simplify that, whatever you tend to say. So I look at this and I say, hey, I could divide both of these by 9. And if I divide both of those by 9, that's going to leave me 4 on the top and 3 on the bottom. And isn't 4/3 a whole lot easier to think about than 36/27? It's definitely easier to say. So we always like to reduce our ratios. 4/3 is my value of that particular ratio for that triangle here on number 4. Okay, same idea on 5. We're looking for the sine of x. So again, if we're looking for any ratio about x, we label it as such. So this side across here would be the opposite. Find my 90, this side over here then would have to be the hypotenuse, leaving me the next two side over here, the adjacent side. Now sine, that would be SOHCAHTOA, so And again, you can't spell it, it's really worthless, so make sure you can spell SOHCAHTOA. S-O-H, so sine is opposite over hypotenuse. So the opposite is 24. The hypotenuse is 30. Again, 24/30ths, kind of a large fraction there. I'd love to reduce that. So I happen to know that both of those numbers will divide by 6. And so 24 divided by 6 is 4. 30 divided by 6 is 5. So 24/30ths is the same thing as 4/5, which again is a much simpler ratio to say. All right, and last one of these, cosine of z. Hopefully you're getting this by now. We're going to find z. Everything is related to where z is on your little map here, your triangle. So again, go all the way across. That's the opposite side. Find your 90-degree angle across from the 90-degree. That's your large side here. That's called the hypotenuse. And then finally, we've got my adjacent side over here. This is the side next to the z. That's not the hypotenuse, so it's called the adjacent side. So we've labeled everything SOHCAHTOA, so we're looking for cosine. So SOHCAHTOA. I like to write the part that I need. That would be adjacent over hypotenuse. So I find my adjacent side, which is 28. I find my hypotenuse side, which is 35. Again, 28/35, fairly large, but both of those numbers suspiciously look like they divide by 7. So 28 divided by 7 gives me a 4. 35 divided by 7 gives me a 5. So that ratio also boils down to 4/5. So at this point, we have identified the ratios for each term. We have been able to use them inside of a triangle. Now we're going to actually use them to find a missing piece. We've simply just been identifying ratios. So now we're going to use that ratio to solve it with algebra. So looking at 7 and 8 here, we're missing on each one a side length. So let me go ahead and just circle this. I'm looking for that side length right there. Now I was given an angle, and to be fair, since I know that all triangles add up to 180, since I know that's 90 and I know that's 36, if I wanted to, I could figure this angle out as well, and I could work from this angle. But since this angle's already written, we'll just go from here. So let's say this is the angle that I'm starting from right here. I won't use an X since I've already got an X there. So I'm starting from this angle right here. I'm going to label my triangle. So the side over here across from it is the opposite. Find my 90. Across from my 90-degree angle is my hypotenuse. And this side over here by itself next to the angle is the adjacent side. I didn't get any markings there anyway. Alright, so looking at my picture here, if I start from this angle, I've been given the opposite side is 13, and I was asked to find the hypotenuse side, which is labeled as an X because I don't know what it is yet. Okay? So an O and an H would create the sine ratio. So if I'm given the O looking for the H, the ratio that has both of those sides in it for comparison is the sine ratio, SOHCAHTOA. So what I'm doing is I'm looking for the sine of, now we always look at the sine or the cosine or the tangent of the angle. So I'm going to look for the sine of this angle up here, which I'm going to write 36 because I already know the degree. The degree of that angle, the size of that angle is 36 degrees. So sine of 36 equals opposite 13 over hypotenuse X. So now I've got the ratio of my angle, and it's O over H. So if only I had a way to solve this. Well, that's where your calculators come in handy for you. Now keep in mind, every time you do anything in trig with sine, cosine, and tangent, at least currently, you want to make sure that your calculator is in degree mode because we are dealing with degrees here. Radians is another topic for another day. That's another measurement system that we're not using right now. So when we're finding degrees, make sure that our calculator is in degree mode. Otherwise, you're going to be getting answers that are in radians, which is like expecting miles and getting inches. It's not going to work out for you. So I put it in degree mode, and I need to figure out what the sine of 36 is. Now your calculator has every ratio in it stored. And so I see that the sine of 36 is 0.587785 blah blah blah. Now we're going to round that off. Let's say we round that just to 0.59. 2 decimal places sounds good. Actually, let's round it to 1 because it, gives me directions. Round to the nearest tenth. I guess I should read. So that would be 0.6. So I know the sine of 36 is 0.6, and I know that that equals my sine ratio of opposite over hypotenuse. So 0.6 equals 13 divided by x. Now, you want to solve for x. X is in the denominator. We don't really like it to be in the denominator, so we're going to multiply both sides by x. And you say, well, that didn't help me. I multiplied by x, and I still have the x. It just moved over to the left side. You're correct, it did. However, we got it out of the denominator, which, until we get it out of the denominator, we can't really work with it. So we go ahead and multiply both sides by x. That gets it out of the denominator. Now we can divide both sides by 0.6, and that will allow me to figure out what x equals, which, if you type it in, is 21.7 rounded to the nearest tenth. So that is the length of that side of the triangle, 21.7 units. It doesn't tell me. Are these inches? Are they centimeters? We don't know. 21.7 units long. All right, so let's work through that same problem on number 8. Number 8, I've been given this side up here. Now, since I was told this angle is 64, and again, if I'm told 90 and 64, I can figure out the other angle if I wanted to, but since this one's written, we'll go from here. So from this angle up here, this side across would be the opposite. Here's my 90. Find the 90. This side across from that would be the hypotenuse. And then this side over here next to it is the adjacent. So in this particular problem, the opposite is the one that I was not given any information about and I don't need to figure out. I have the hypotenuse, it's 19, and I'm asked to find the adjacent side, which is labeled with an X because we don't know it. So if I'm looking for A and H here, that would be SOHCAHTOA, cosine. So I'm looking for cosine ratio here. The cosine of that angle that I was provided, 64. Okay? We don't have to say the cosine of theta or the cosine of A or anything because we know the degree. The degree is 64, so that is my ratio I'm looking for here. So what is the ratio of a 64-degree angle in the cosine pair of sides? And that would be adjacent x over hypotenuse 19, A over H. Now again, I don't know what these ratios are just off the top of my head, but the calculator does because it remembers a lot more things than I do. So the cosine of 64 degrees is 0.438 blah blah blah, which if we're rounding to the 10th, we'll just say 0.4. So 0.4 equals x divided by 19. Now this one's a little bit easier than the last one. I've got divided by 19. To get rid of a divided by 19, you simply multiply by 19. And in so doing, we get x by itself pretty quickly. So x equals 0.4 times 19, or 19 times 0.4. Either way, 7.6. So in this problem, I was looking for that length right there of that side, and I see that it is 7.6 units long. Okay, now, while 7 and 8 were using algebra to solve to find missing sides, 9 and 10 are to solve finding missing angles. And so in number 9, here's the 90-degree angle. We're asked to find this angle right here. So we're asked this time to find an angle. Now, I don't know what the angle is, of course, because that's what I'm looking for, but I do know that across from it, the opposite side of it is 8. I also know that my 90-degree angle is right here, so this side over here is the hypotenuse. There's nothing written, but that does help me identify that this last side over here next to it is the adjacent. So you are given the opposite side, which is 8 units long. You're given the adjacent side length, which is 27 units long, and you're asked to find that angle. Well, I know that every pair of sides has a corresponding ratio that I could then use to maybe try to figure out that angle because of SOHCAHTOA. So here I am with OA, that would be TOA. So I know that the ratio that is going to find this pair of sides for me is tangent So I'm going to try to work backward here. I don't know the angle. So if I call that question mark an x, I could say the tangent of x, meaning that angle here, the tangent of x is identified as the ratio of opposite over adjacent. So 8 over 27. Now, here's the problem. Tangent of x means the tangent of the angle. I can't type that in the calculator because I don't know the angle. I know the other side. 8 over 27 is that fun little decimal right there, which, if you turn it into fraction, is still 8/27. But that doesn't help me. So what I need to do is think about how you solve any equation. Solving any equation requires you to do inverses. For example, I come all the way to the top. Let's go simple. X plus 1 equals 3. How do I solve this? Well, you might say, well, the answer is 2. Yeah, but how do I solve it? Well, to solve it, you would simply say, well, I've got a plus 1 over here with x, so I'm going to subtract 1, because plus 1 minus 1 is 0. It's going to go away, but you can't subtract on one side without subtracting on the other. This plus 1 minus 1 is an inverse operation. Everything you do to undo something else is called an inverse. So the question is, if I want to get x by itself, that's the goal, how do I get x by itself? Well, I have to get rid of this tangent. Well, how do you get rid of a tangent? What is the inverse of tangent? And we find that the inverse of tangent is actually, it's right here. It's called inverse tangent. And so there's a button on the calculator that does the inverse operation. So what actually happens, basically, is that you're going to do the inverse tangent of both sides. Now, what do you suppose happens to tangent and inverse tangent? If you guessed that they cancel each other out, you are correct. So the inverse tangent of tangent is simply just the angle, which is x. Now, that means that on the other side, we also had to do the inverse tangent as well, because again, if you do something on one side of an equal sign, you do it on the other. And so I know that to find x, I simply can type in inverse tangent of 8 over 27, and I don't know what that is, but again, that's what my calculator's for. Inverse tangent of 8 over 27, or if you want to write it all with your fancy math tools on your calculator, you can write it like this. Inverse tangent of 8 over 27 gives me 16.5 and a bunch of other decimals. It says round to the 10th. Oh, this one says round to the nearest degree. It's changing directions on me. So rounded to the nearest degree, 16.5 would have to round up to 17 degrees. So that is my angle right here. One more time on number 10. So on number 10, we are looking for this angle right here. Now, this one I'm given every side length, which means you could pretty much use any ratio you wanted. So if I use this pair right here, this across is the opposite. Here's my 90, so on this side would be the hypotenuse, which leaves this to be the adjacent. I can pick any pair I want because I was given every side length. I'm trying to find this angle though. So let's say I want to use the O and the A. Well, that would be TOA, tangent. So that would be tangent of, we'll call that question mark x. I don't like using question mark for a variable. It looks weird in the equation. So tangent of x is equal to TOA, opposite 6 over adjacent 8. Now, just play devil's advocate here. You say, well, what if I didn't want to use that? What if I wanted to use a different one? Okay, well, what if you wanted to use the opposite and the hypotenuse? What if you wanted to use these two? So OH, that would be SOHCAHTOA. So OH, then I could say, well, what if I did sine? What if I was looking at these two? So that would be sine of opposite 6 over hypotenuse 10. Either one of these could work, and you could actually do one for cosine as well, but I'm running out of room. So what if you picked this and you did it based off of tangent, which is opposite adjacent 6 and 8? Well, then you would take the inverse of both sides. Remember that the inverse of both sides is going to cancel the tangents out. So to save myself some room, that's really all that happens, is that you take the inverse of the other side and you got your x by itself, and you get inverse tangent 6 over 8, 36.86, which if you round that to the nearest degree would be 37. degrees. What about this guy over here that didn't use tangent? He used sine. Is he going to get the same answer? So let's try. So if you want to get x by itself, take the inverse of sine. And again, it's going to cancel on the left, leaving it just on the right. So I'm trying to just kind of shortchange it a little bit here. If you wanted to write every step out, you could. It just, once you see what happens, it's kind of unnecessary. So the inverse sine of 6 over 10. Lo and behold, it gives you the same answer that the tangent did because it should, because it's the same angle. So those ratios are just showing you that they're going to provide you the same answer. So 36.86, again, rounds to 37 degrees. So if you're given every side, it doesn't matter which two you pick. You can pick any pair you want so long as you use the correct ratio. And if you use the correct ratio, you're going to get the right answer either way because that's how math works. All right. Now, let's apply this to a little bit more difficult problems. Looking at 11 and 12 here. On 11 and 12, you're given a side defined, but you're not given it inside of a single triangle. You're given it, well, you are, but you're given it inside of a triangle that's been broken into two right triangles. And unfortunately, you are not given enough information on the first triangle to figure out what you need. So what we do on a problem like this is we say, okay, this angle right here is 24 degrees. So if I labeled just based off of this triangle right here, this is the opposite side. Here's my 90 on this one. So that would make this the hypotenuse, making this the adjacent. So ignoring all of this, looking at that triangle right there, this is just like it was on the page before. So I've got the opposite side is 5. Would it be helpful to find the hypotenuse, or would it be helpful to find the adjacent? I would argue that it would be helpful to find the adjacent side because that's a part of this triangle, which is what I'm trying to look for later anyway. So I want to find the adjacent side. So I'm going to label that. I would label it x, but there's already an x over here. So to avoid confusion, let's label it y. All right, so the opposite side is 5. The adjacent side is y. So if I'm looking for opposite adjacent, that would be TOA. So I'm going to use the tangent ratio. So the tangent ratio of 24, because that's the angle that I started from up here. So the tangent of 24 would be opposite 5 over adjacent y. I don't know what it is. Okay? So again, I need to solve this. I don't know what the tangent of 24 is, but my calculator does. I type it in. It tells me it's 0.445. It says round to the nearest tenth in your answer, so we're just going to use 0.4. So 0.4 equals 5 over y. Now again, I need to solve this with some algebra. The variables on the denominator, I don't really like that, so if I multiply both sides by y, 0.4 times y, very quickly I get the y off the denominator, looking much more normal. Then I can divide both sides by 0.4, leaving me with 12.5. Okay, now you say, oh, I'm done. No, 12.5 is y. Y is what I just made up to describe this length over here, this side. It's not what I was asked to find. So it was a side that's to help me figure out what I was asked to find later. So y equals 12.5. Now, you're supposed to find x. So now ignore the left triangle. The left triangle helped you figure out this length here. Now let's look at it. So this is really a two-problem problem. I was given this angle here. This angle here is 37 degrees. Now, in relation to this angle here, this side over here is the opposite. This side here is the 90. This side over here is the hypotenuse. And this side down here is the adjacent, then by default. So if I have my 37 degree angle, here's the opposite side over here. I need the adjacent side. So again, that would be TOA, tangent, opposite adjacent. So looking for tangent again, tangent of 37 degrees is opposite 12.5. That's the number I found before, over adjacent x. I don't know tangent of 37. Now I do. It's 0.8 if I round to the nearest tenth. Running out of room down here, so 0.8 equals 12.5 divided by x. Well, I need to multiply both sides by x because I certainly don't want the x in the denominator. And let me shoot over here because I'm out of room. So 0.8x equals 12.5. That got the x out of the denominator, so my last step here, divide both sides by 0.8. X equals 12.5 divided by 0.8, which is 15.6. So that length of this side right here is 15.6. So let's do that one more time here on 12. Now I was asked to find this over here. If I was given either of these two sides, I could be done in just a minute, but I wasn't. So I need to utilize my information over here to figure out this side or this side. This side is the one that would help me, so I'm going to find this side first. And if I can figure out that side, then I'll use this side to help me find that side. Alright, so ignoring this, looking at the triangle where I have a little bit of information. This angle here, I need to find the opposite. And here's my 90, so I am given the hypotenuse. So O and H are the two adjacent over here I don't care about. So OH, that would be SOHCAHTOA, so sine. So the sine of 43 degrees equals opposite, which is y, over hypotenuse, which is 16. Now the sine of 43 degrees, using my calculator over there, is 0.7. And then if I want to get y by itself, pretty simple on this one. I can just multiply both sides by 16, and y is already by itself. 16 times 0.7 gives me 11.2. Alright, so I know that y is 11.2. Now again, that's not your answer. We found this side length right here. Y was 11.2. So now we're going to utilize that information to solve using this right triangle over here to find x. So now I look at this 32 degree angle. And again, 11.2 over here, this is the opposite, so I'll just leave that O. It's still the opposite side for this angle as well. And here's the 90, so this side that I'm looking for is the hypotenuse. So again, OH is still SOHCAHTOA, so sine of 32 degrees. Now be careful here, this one, the opposite is the 11.2 over the hypotenuse, x. So I need to find out x again. So a little bit of algebra and I'll be done. The sine of 32 degrees is 0.529, so 0.5. Multiply both sides by x because I don't want to have, I'm going to fix that, let's see, there we go. Because I'm going to have an x in the denominator, so now I've moved that x to the numerator, getting rid of that fraction. Divide both sides by 0.5. 11.2 divided by 0.5 gives me 22.4. So the length of x that I was looking for from the beginning is 22.4 units long. Alright, so now some word problems. So 13, we've got all but 2 of the pyramids built by the ancient Egyptians have faces inclined at 52-degree angles. Tell you what, just for the sake of making this simpler here and having 2 videos instead of 1 to help you divide it up, let me go ahead and stop there. I'll make a second video for word problems and let you kind of divide that up between the 2 videos. That way if you need help on one part or the other more often, it'll be easier for you to find it. So come back again if you need the word problems on the next video.